Hello and welcome to Empowered Learning. This particular lesson will be on how to derive the Pythagorean identities as well as the reciprocal identities for trigonometry. We start off by looking at the unit circle because we know pretty much everything that we do in trigonometry at some point in time will come from the unit circle. So as you see here, I have a unit circle drawn, and if I make an angle theta here from the x-axis and I spin it counterclockwise, which we call standard position, and stop at some point here, then from the origin up to this point forms the terminal side. So with that, of course, if we draw a line that comes straight down here that intersects the x-axis perpendicular, then we end up forming a right triangle. And so on the unit circle here, we know that this is a circle that has a vertex at 0, 0 and has a radius of 1. So if we see that, then of course what r is representing here, which is going to be the radius of the circle, would indeed just be 1. So we'll go ahead and put that here now. Now, of course, we see that at this point has an x coordinate and a y coordinate. Okay, and so since this is a unit circle, the length from here to here would be x, and the length from here up to here would be y. If we just took that particular right triangle and extracted it out of the unit circle, it would look like this. Okay, and so we know that with the unit circle here that the connection is that this x coordinate here is the same thing as cosine of an angle, of this particular angle, theta. And we know that y, which is the vertical component, is sine of this particular angle. So if we look at it like this, take that particular right triangle out, then what we could say here is that instead of calling this x, we could call this cosine of theta. And instead of calling this y, we could call this sine of theta. And of course, we know that this length here matches this one, which is just 1. Now, we know that the Pythagorean theorem tells us the relationship in between the sides for any right triangle. So if we come and write that, we know that that's a squared plus b squared equals c squared. We pretty much learn it that way when we start off. In this case, we would be doing x squared plus y squared equals, in this case, r squared. And of course, x is going to be cosine theta, y is going to be sine theta. So if we come and do that, then this would be cosine squared theta plus sine squared theta, and that will equal 1 squared, which of course is just 1. And so we normally write this as sine squared first and then cosine squared second, but it doesn't matter. And so this would be our fundamental identity, or the Pythagorean identity here, whenever we are using the unit circle. And so this is how we do this. So now what I'm going to do is show you, now that we have this particular identity, from that we can form the reciprocal identities as well. And so I'm going to go ahead and erase this part and just put sine squared theta plus cosine squared theta equals 1. And what I'm going to do to make this process a bit more simple to do, I'm going to let s equal sine theta, and I'm going to let c equal cosine theta. Now, if we look at it this way, then we have s squared plus c squared equals 1. Now, to get the reciprocal identities, what we can do is we can take this particular equation now, or this identity rather, and we can divide both sides by s squared and then divide it again by c squared. When we divide it by s squared, this is what we get. So of course, if we split this up, we will have this. Now, of course, anything divided by itself is 1. And if we look here, this represents cosine squared divided by sine squared. And we know that cosine divided by sine is going to be the cotangent function. So we will write this as cotangent squared theta. And we know that 1 divided by sine is going to be cosecant. So 1 divided by sine squared is cosecant squared. So from that, we see that we have 1 plus cotangent squared theta equals cosecant squared theta. And that would be one of the reciprocal identities that we will need. Okay. So from here, I'm going to note that up here. And now we're going to do this again and now divide both sides by c squared or cosine squared. So of course, if we do that, then we have sine squared over cosine squared plus c squared over c squared equals 1 over c squared. Of course, we know here sine divided by cosine is just going to be tangent. So sine squared divided by cosine squared is going to be tangent squared. And of course, c squared divided by c squared is 1, and 1 over cosine is going to be secant. So 1 over cosine squared is going to be secant squared. And so with that, we have our other reciprocal identity. So we have tan squared theta plus 1 is equal to cosecant squared theta. And so with that, we have our basic fundamental identity, and we have the two reciprocal identities. And so whenever you're doing problems and you see that you need to use an identity, or you see something that may look familiar, my suggestion to you is you always start off with the sine squared plus cosine squared equals 1. And instead of memorizing these, you can always derive this particular one by dividing both sides by sine squared, and deriving this one by dividing both sides of your Pythagorean identity here by cosine squared. And so this concludes the lesson on deriving the Pythagorean and reciprocal identities.